Right, so now we're going to look at our third type of study. Our third type of study is a controlled experiment. In a controlled experiment, researchers take control by assigning subjects to the control or treatment group to ensure that the two groups are nearly alike except for the treatment. Right? So here, this isn't a story. This isn't something that's just being observed. This is something that has been well thought out, well planned, and well executed. Right? This type of study can answer cause and effect questions and show causality. Right? So our first two type of studies couldn't. Right? Only this one is able to show our causality. Right? So as we're thinking about our controlled experiments, there's a few different things that controlled experiments need to have. So a well-designed controlled experiment has 4 key features. Right? So the first is a large sample size. So the sample size must be large enough to observe the full range of variability in the subjects we are studying and allow small differences to be noticed. Right, so we talked a little bit about population versus sample previously in this chapter. So here we are taking the idea of sample. Right? It's a smaller group drawn from a population, and our sample size needs to be large enough. Right? Controlled and randomized is our second feature of a well-designed controlled experiment. Right? Random assignment should be used to assign participants to the treatment and control groups. This helps to balance the groups, which makes them comparable. Non-randomized assignment may lead to bias, right? Which means the results are influenced in one particular direction. The idea of the word random is going to show up as we continue to go throughout the semester, and so is the idea of bias. Right? So we want to make sure that we use random assignment in a well-designed controlled experiment. Right? Our third feature, double blind. Right? So what that means, in blind experiments, an independent party assigns the participants to the control and treatment groups. Right? So some other person, right, is assigning the participants to the control and treatment groups. The participants don't get a choice in which group they are assigned to. An experiment is referred to as double blind when neither the researchers nor the participants know whether the participants are in the treatment or the control group. This helps prevent bias from the participants knowing that they are being treated differently, or the researchers either treating or evaluating the participants differently. So the idea between these two, one we're thinking about blind experiments. Blind experiments means the participants don't know what group they're in. Double blind experiments, neither the participants nor the researchers know what group they're in. Right? So maybe some sort of third party is assigning them to these groups, and the participants and researchers won't know which group these subjects were in until the experiment is over. Right? And then the fourth thing, a placebo, if appropriate. A placebo is a look-alike treatment given in place of the actual treatment. Right? These may be used in controlled experiments. Some evidence of the placebo effect, which is a psychological wish fulfillment where we feel better because we think we should be feeling better. So sometimes when we're dealing with certain experiments, this is something that could happen. To neutralize the placebo effect, it is important that both groups receive similar attention. So the idea of a placebo, one of the easiest examples is maybe if we're testing some sort of medication, right, where we're giving one group a sugar pill, giving one group actual medication, and the people that are taking it don't necessarily know which they are getting. Right? The placebo effect would be people taking the sugar pill, showing less symptoms or feeling better, even though they aren't necessarily getting the medication because they think they should be feeling better. Right? But placebos help to, even though this effect is possible, helps to kind of even everything out, right? And so as far as our experiment goes, to make our groups as similar as possible. All right, so in this example at the bottom, we're going to think about our last two types of studies. Right, our observational studies in a controlled experiment and decide which one is which. There's definitely a few homework questions along these subject matters in your homework for section 1.5. So a student watched picnickers with a large cooler of soft drinks to see whether teenagers were less likely than adults to choose diet soft drinks over regular soft drinks. Right, so looking at this, a person is just watching, right? That is the definition of observing. Right? This is an observational study. Right? So an observational study of groups, there isn't all of those nice 4 key features that we just saw in our definition of controlled experiment. Right? We aren't controlled and randomized, we aren't double blind, and things along those lines. So that's an example of an observational study. Right, for B, a group of boys is randomly divided into 2 groups. One group watches violent cartoons for an hour and the other group watches cartoons without violence for 1 hour. The boys are then observed to see how many violent actions they take out in the next 2 hours, and the groups are compared. Right, so here we have split the people into categories. Right, we've split them into 2 groups. We can only hope or assume they were randomly assigned. And then we have a controlled group, we have a treatment group, and then the results are studied. Right? This would be an example of a controlled experiment. And remember, as we're going through this section, over and over again, we keep saying observational studies cannot show causation, but controlled experiments are able to show causation.